All right, I want to talk about section 9.3, simplification of radical expressions. Now you might think, woohoo, radical expressions. Well, radical means something specific in math. A radical is what we call this symbol. So a radical expression in math, unfortunately, simply means that it contains a square root in it. And what we're going to be looking at is how to simplify some expressions. Now recall again that expressions, they do not have an equal sign. They're things like 3x or 12x minus 7. Or in this case, the one that we're going to be looking at in the beginning, we're going to have 2 times the square root of 4 plus 7. And the question is, how do we simplify that? Well, it's pretty much the same that we've been doing before. We're just going to be doing that PEMDAS method that we've been looking at before, and we need to make sure that we do it in that order. So recall PEMDAS, right? So we have parentheses, exponents, multiply and divide, because they're really the same thing, and add and subtract, because they're really the same thing. But our exponents, they contain our radicals. And that's really going to lead us towards what we need to do. So let's take a look again at this symbol, and we'll bring it back down to keep looking at it. We have 2 times the square root of 4 plus 7. Well, if I go through my steps, so my parentheses, I don't have any parentheses in this case. Next, my exponents contain the radicals. Okay, so I'm going to simplify all of my radicals. Square root of 4, what times itself is 4? Well, that's 2. So I can rewrite this as 2 times 2 plus 7. Okay, next question is, what do I do next? Well, if I continue any more exponents, no more exponents. Multiply and divide. Okay, got my multiply and divide. 2 times 2 is 4. 4 plus 7. Lastly, I'm going to get to do my add and subtract, and I have 11. And that's pretty much how this section's going to go. It's pretty much just making sure that you do things in order and making sure to remember all of those implied multiplications and all of those different tricksy ways that they can write different things. Let's look at another quick example before we go. This one we're going to write 6 plus the square root of 9 minus the square root of 49 plus 5. Okay, again, I'm going to be referring to my PEMDAS that I have above. No parentheses, but I do have exponents, my radicals. So I'm going to do both of my exponents because they don't need to affect each other, so I can do them both at once. So I'm going to have 6 plus 3 minus square root of 49. What times itself is 49? 7 plus 5. Now I don't have any multiplication and division. I can skip that whole step and go right to my adding and subtracting. 6 and 3 is 9. Minus 7 plus 5. I'll do 5 and 9 together. That would be 14 minus 7. Oh, that's a terrible 7. 14 minus 7 is 7. And ultimately, that is the answer that I'll get to. We need to remember order of operations, remember the associative commutative properties, and remember what can be added and what can be subtracted in the correct order. That's pretty much all that you're going to do in this section. It should not be too bad. And it looks like all of the radicals are perfect squares, so that'll be really convenient. We won't have giant decimals to deal with. All right, good luck.